Okay, we're back again for Advent of Code 2022. It is now day 19. Hard to believe there's only a week of the competition left, which means 7 more days for me to try to get points. Unfortunately, the streams will probably be coming to an end shortly, as I will be traveling back to Vancouver to spend time with family and stuff over the holidays, and I'm not bringing my PC that's capable of streaming along with me. So I will still be doing Advent of Code when I can from 9 PM PST on the West Coast, and I'll do my best if my laptop can handle to record and upload the solves after. But yeah, I don't think I'll be streaming past the next couple of days at least, depending on how my schedule is looking. But it's been a fun month, and it's been really cool having people comment and watch and like tune into the streams. So I really appreciate that. But yeah, I think the goal is hopefully getting some points over the next 7 days. Each of these is one line. Like, it's kind of annoying. I don't like when the inputs are not formatted the same way as they actually are. Okay. More elephants. So every turn I wonder if you need a star for this. The quality number is blueprints. largest number of geodes, so we're trying to maximize geodes. 24 minutes for the state is probably minutes in bots. Play bots. Bots and geobots. And the amount of each thing we have. Okay, so we're at minute 1. We have 0, 0, 0, 0, 0, 0, 0. Minutes 1, 2, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4. I feel like this is definitely gonna be too sad. Otherwise, oh, we start with one ore bot.
I was able to defend my homeland. It's a familiar sensation. Oddly soothing.
So it's gonna be ore. It's gonna be added by the number of ore bots we have.
Kakarot, I think I understand now why you've always been so strong.
How about we skip the introductions and get right to it, okay? Fusion!
So the possibilities are I guess it's ore cost, okay? We could build one of these bots. This might be completely stupid. In my head I haven't computed how bad this is. like this feels like the question where you need a star to solve it, but I'll just encode the logic and then I can, I guess, copy it over after.
I understand now why you've always been so strong.
Oh, or do nothing. Does it cost? Oh, it costs obsidian. Cost ore and clay, you cost ore and obsidian. In all of these I never... Really? How come we are not building any we are never adding any clay for some reason. Spend 2... Oh. Or you use ore to buy that. Okay. Should not be going negativo. Oh, yeah. It's a little confusing, I would say. How big is the actual input? And I just want to confirm that the logic is correct. Maybe we can... I mean, we want to get to the geode bot as quick as possible. So maybe we do a priority queue. Let's make sure we understand the problem right. Okay, no, I think the logic is correct. It's just the search space is way too small. I mean, the search space is way too big. If we restrict this down to like 20? Seven. That doesn't seem right. Like, I'm pretty sure it's like 5. How could we have gotten 5 geodes? Let's simulate out to time equals 10 and compare our clay count. Yeah, it's a little suspicious. 15 clay. I guess. Am I supposed to not be +1 anymore? Time. So at the end of time we check the state, right? So I guess it should just be, well, it'll be after it's processed. At the end of 1 minute we have 1 ore, so I think this is actually right in terms of being off by 1. So the search is too slow, we do need to prune the state a little bit more. Is the input special? Like, can we just always afford to be greedy? We just want to make a geode robot, if ever possible. It's probably true. I'm a little concerned that the numbers seem wrong about the simulation. We could have 2 robots and one of each ore collecting robot and one of each ore. Okay, I guess maybe we can just assume we should be greedy to start. Minute 10. It's saying the best we could do is 9. Maybe the actual key. Wait, what? How can we dip to the negative? This is 4. These are the number of bots we have, so we somehow dipped negative into the clay. We're adding a geobot, and we're spending ore. Oh, this should be geo ore. Okay, wrong number again, but better. Let's just double check. This costs ore and clay. Okay, add a bot. We minus ore and our clay. Wait, no, this was right. Even though the naming is bad. Right, it's ID number, ore cost, clay cost, obsidian ore, obsidian clay, geo ore, geo obsidian. Data seems better. Maybe we can assume the next state is in here. We always just want to do something strictly better? Let's just simulate to minute 5, please. And make sure we have a state that says, actually, on minute, if we do minute 11, we should have states where we have at least one obsidian bot, so this value here should be 1. We should have a state that's like 12, 1, 3, 1, 0, and then we should have a 2, 4, 2, 4, 0, 0, right? Yeah. Okay. So we hit the right state, which is good. If we simulate out to move 20, whoops, we should have a 1, 4, 2, 2. And then 3, 29, 2, 3. Is this still too many states? Seven? I think that logic seems reasonable. Oh, maybe these are the useless states. If we have a bunch of ore, we would never want to do nothing. And if we have a bunch of clay, we would never want to do nothing. Right? cost, clay cost. Ob ore, geo ore, and then max cost on clay is ob clay. It's just the ore that, because this uses, these three use ore to build and this one, so maybe we'll just try this. If ore is less than or equal, or less than max ore, then we treat that as a possibility. So we're not running huge ore excesses now, but we're running huge clay excesses, which is kind of problematic. There's no reason we wouldn't use the clay to do. And clay is less than. What is it? Ob clay. Like, we shouldn't be getting into the situations where we have such a huge excess of clay. Well, I guess clay does cost quite a bit, right? The only thing that clay is good for is the obsidian robots, so... I'm mostly just curious if this gets the right answer. We have a bunch of these robots. It's like some sort of... Can you do some sort of heuristic? Like, what's the heuristic? We want to get closer to producing geodes? perhaps it is an A star of some sort. But how do we translate that over? Like, we have so much excess ore. Maybe the heuristic is that if we ever have enough to make, we just stop making ore bots past a certain point. Oh, maybe like past the cost of max ore. If and what is it? Would be ore bots is less than equal to max ore. Well, I guess it would be clay cost plus that should prune the state quite a bit because we don't waste time making like a bunch of random ore bots that are unnecessary, and I think we can do a similar thing with the clay. We never need I guess we don't get to that point. Wait. We collect the resources, and then we'd have 2 coming in. We would collect. Oh no, that's right. Okay, I guess it's perhaps just a heuristic thing. We just try to optimize for maximum geodes produced, but I don't know. Will this even improve anything? Oh, I wasn't doing that properly. Maybe that's why I didn't notice any tangible benefit. These numbers seem too big. Like, it shouldn't be possible to produce that many fields? I mean, we should only be able to produce 9. But it looks like we're getting some pretty big numbers. Yeah, still too many states to check. Oh, how do we visualize this? The dreaded day 19 spike. So that's the priority, we ignore it. We advance in time. Everything else stays the same, but we... So this we just collect resources based on what we have. Which should be true? here we prune state if we've seen it and we're smaller than everything we've seen. How often does this hit? It's actually pretty infrequently. Anything special about the input here? This is gonna take forever to run. Is the greedy solution strictly the right thing to do? I guess this only adds states where on every given turn we do one of those things. But actually I can anticipate you having like so many ore bots that the amount that you add lets you add a bot and also go to more advanced robot. Like, it probably happens in the example here. Unless there's a rule against spending and building two things in one turn. It's like we stopped building or collecting robots. But I don't know if this greedy solution is actually optimal? That would be my question. Like, okay, yeah, here we backtrack. Cause like we had nothing better to do, we happened to. Like at a certain point, I guess we just would always Like our bottleneck here is just never this ore robot? That runs so quickly. Even if we remove this, we're just getting the wrong number. Like it should not be possible to be. I guess this is the answer we want, right? 1-6 with 61 pay. I don't know. Having like 9 geodes or something like that. 1 ore collecting robot. 2, 3. How did we get another geode collecting robot somewhere? We cheated. Somehow we were cheaters. Let's try just simulating to minute 20. I feel like these ones where we have extra geodes makes no sense at all. We're getting extra resources or extra geodes where we're not supposed to. But I cannot quite figure out where. We go to bot because we spent ore and clay to do it. We go to spot because we spent ore and obsidian to do it. Go to playbot, we spend ore to do it. A 1-1. Any 1-1-2-1s? Okay, the fact that we don't have a 1-1-2-1 state here is weird. Right? So at minute 1, we obviously have 1 robot, 1 ore, like this. After minute 2, we could either have hoarded or we would have had 2. Oh, we have to spend before we start building. So I guess okay, I see. Yeah, I see. So we either have 1, 1, and 1, or I guess the alternative. Okay, this seems like a bit more valid. 9? Okay, sure. Did I just get lucky? We can do better than 9. Maybe we'll remove some of these restrictions. Oh, why does this take so long to run now? For our second blueprint. Hello? Are we infinite looping? Like again, we're just hoarding so much ore. So let's put this back. guess the optimization's actually here, right? Looking for a 12. Great. Okay, well, this might be it. It's too low. Okay, 956 is too low. So we could do better. Let's dump some more heuristics in. Or let's okay, we get 956 again, so I feel like that's probably not it. Well, I mean, this is gonna be really hard to debug. Like, really hard to debug. Because I feel like this is ridiculous to simulate. Okay. This one, for sure, we can get to something. Maybe this is a good test. Is it possible to get to 16 obsidian at all? Because if it isn't, so it'll take 1, 2, 3, 4. We make a clay. 1, 2, 3, 4. Make another clay. That's 8. Then 1, 2, 3. Four, we make another clay pot, so we're making 2. Yeah, I guess there just isn't enough time. Oh, is this the binary search question? It's like, is it possible to is it a working backwards type question? No, that seems too difficult with the time like transitions. Oh, did we just luck out with the sample input? Do we have this exact state, I guess is the important question. We don't. And our prediction was too low, so we're pruning too many states. We think we can build 6 clay bots. We have fewer ore. Okay. Maybe if we don't prune states. No, I think it's useful to do this. still not what I expected. This actually speeds up the search a lot, and I don't think there's any downside to it. Let's go back and trace what we're doing again. By minute 3 we should have 1, 1 and 1 left. By minute 5 we could have 2 clay robots. Boom. Oh wait, no. 2 clay robots, 1 ore collecting robot, 1 ore, 2 clay. Great. By minute 7 we can have 3 clay collecting robots, which is here. We still have 1 ore robots. We have 1 ore, 6 clay. Okay, by minute 10 or minute 9 we can have 1, 3, 1, 3, 3, 12. That's this state right here. By minute 11 we could actually have an obsidian bot. So we can't have an obsidian bot until this point. But if we increase to 12, minute 11 we can have 1 ore collecting robot. We could have a 1, 3er. 1, 3, 2, 4. Or no, 1, 3, 1, 2, 4. 1, 3, 1, 2, 4. That's this state. By minute 15, I'm looking for a 16. What it'll be? 1, 4, 2, 0, 1, 5, 4. This is similar, but we're not subtracting enough clay. So this would have been derived from this state before it, in which we should have 1, 4, 1. One for 1, 3, 15. 3. I guess that's easier to just search the ore counts. Let's look for 211.2. Okay, that doesn't exist, so something broke here. Let's look for, I mean, 2.4 is here, right? We got a 1.3.1er on 12, 1.3.1, 1.3.1.2.4. This is good. But here we fall apart, because we're looking for a 1.3. We're looking for a 1.4.1. where we collected an obsidian like this. But the clay count is wrong. We should have 7 clay. Are we adding too much clay somehow? I mean, doesn't seem like it. In order to build one of these, we remove that amount of clay. In order to remove one of these, let's just make sure we're reading the input properly. Ore cost, clay costs, obsidian ore cost, obsidian clay cost, geo ore, geo obsidian. Oh, did I type wrong? Nope. Seems fine. This seems fine. So our simulation is accurate until minute 11 or something like that. Because we have a 4:15 here, which is exactly right, but it doesn't transition to the right state. So we have to figure out what happens to the 4:15 here. At this point, we should be able to build an obby here. Oh, we don't have any. Oh wait, no, we do. It's these ones. How could we have gone from 1-4? Okay, allegedly, we could have had a lot more resources. Okay, I think I probably just have too many bugs in the logic here. 1 ore collecting robot and 3, so 3, 12. Fine, this is great. Or we could have spent an ore there. Yeah, okay, I agree with that. On minute 10, we should get to a 4:15 from here, which is pretty obvious. It's just the natural state transition from 10. But, so this is our good one to go off of. And it should transition cleanly into 131. Spent 3 ore. Our bots made it, so we go down. Oh no, this is it. 13124. Great. So we were 131024. Great. Here we should have a path where we make a clay robot. So we should go up to 14113. There's a couple it could be. 141. There's a lot of 141s. But then there should be one where we have 171 resources. Which is this state. Okay? I mean, things are looking okay. Oh. No. What's everyone? Yeah. Here, there should be a state where we have 211.2. Because we just don't do anything. We have 214.2. But I feel like there's excess clay coming from somewhere that I don't feel like debugging right now. 141, 214. Because how else could we have gotten to this state? Oh. Maybe it thinks we got there from here. Because 10... Wait. How could we have gotten more clay than we bargained for? How could we have gotten to a 110.1, huh? This doesn't make any sense. But I guess it comes from this state here. Whoops. Comes from this. Because in order to build the obsidian bot, we needed to spend 14 clay and we made 4. Yeah, so this exactly comes from this. So this, 140,320 is bad news. You know what? We're just gonna... Because I think this will help identify what the bug is. here was 20. Let's try to interpret this. So, minute 1 we start with a bot. Minute 2 we mine an ore. Minute 3 we mine another ore. Minus 1. Minute 4 we spent 2. We went up to 3. We spent 2 to make a clay bot. Fine. Next minute we generate. We still have the same number of bots, but we get a clay and a thing. Next thing, we spend 2 to make another clay bot. Great. Next, we make more clay and one more thing. That's fine. Here, we spend 2 more to make that. That's fine. Here, we 1, 3, 2, 9. Great. We mined. Here, we spend to make clay. Here, 1, 4. I mean, logically, I think it's all valid. We're just like stacking up all this clay is the thing. Kind of pointlessly because we can't spend it. But I don't think there's anything specifically wrong with the logic. Is the weird part, right? We should have a 1422 here. But we don't. Should I be concerned about that? Any instances of 1422, please? Nothing. Yeah, that means the state is getting pruned out. Maybe we remove these heuristics. No, we're so slow now. That's weird that the state transitions are incorrect. I mean, I guess we could just it's kind of inefficient, but let's do things this way. Because all the mining gets finished too, right? So we're gonna do this and then horizon.extend. It'll be I don't think that this is actually a logical bug, but just to make sure. Where did my ore bot go? My bot just disappeared here, please? It makes no sense. We see the bot here and then the bot disappears. Like, I don't understand where this... Oh, I'm not incrementing anymore for some reason? Oh no, I am incrementing it. It's here though. Why is this ore not being given to me? That is the question that I would like answered. Or rather, I guess the bot just disappears? Can anyone explain this question mark? Why does this 1 turn into a 0, huh? Oh, it's... Okay, fine. Better. Better. One 4 2 2 1 6 2 2. We made 6. Geos. This one might be a sleep angle. Might be asleep on an angle, but we will see. You think it's 6 as well now? We build only if it's a valid operation to build at the start of turn before we harvest. So this is our build. We do the subtraction. We get the thing back. It gets added to the new position. And then Somehow I broke it even more. I wonder what happens if we run it on. This. Yeah, we're like super underestimating. So that's definitely not it. Oh, I don't need to do this anymore. Okay, well, I mean, this is probably just going to result in the exact same answer I tried before, 956. For part 1 at least. I'd be very surprised if the logic changed. Oh, it's a different number. 1366. Still too low. $13.66 is too low, you say? So we want to be a bit greedier. We want to do better than 1366. Let's not filter this state out. I mean, we still run in, it's slow, but it's very slow. We'll let it run and see if we get anything better at least. I'm starting to think this question like wanted you to do some sort of A-star to try to seek the optimal way of doing or arranging this, but or maybe you just like work. It might be a binary search question too, in the sense that it's like, well, is there a valid way to get to 9 geodes? Yes, no, or something else. So that doesn't really make sense to me because it's like time-based, like stuff happens in intervals of ticks. I do think maybe it's like a greedy thing, like if once you get to the point where you're making obsidian robots, oh, maybe it is a binary search thing. like, basically, the answer is 0 if you could never make an obsidian robot before 24 minus 16 minutes. So like, this is feasible to get geodes from if you can have an obsidian bot by minute 15. And can you have an obsidian? And I guess then it's like, oh, when's the earliest you could have a obsidian robot, right? Because the ore is never going to be the bottleneck to build the later types of bots, I feel. So it's like a binary search on when you could make the geode robot? By working backwards greedily and then trying to say, in order to make one geode robot, by that time you would need to have made, you know, an obsidian robot by t equals 15, and to do that you would have had to have made like a few clay robots. How does our search space be looking? Yeah, we're using some RAM. I guess because kind of pointlessly, because we're storing the paths to get to places. That's not helping our search, is it? I somewhat trust this. Oh no, what did I delete? Geog? Is Geog just supposed to be Geo? Oh, I hope so. I don't know if we did anything better here. Paste me. Oh, it didn't copy out. It is still kind of tricky because every there's like many possibilities of how you could create enough obsidian this early, or even going up to create, like spending, I guess you spend any excess clay to make extra obsidian and you just try to max out your geodes. I'm not sure if this will actually terminate. We're stuck on blueprint 17. I guess it's one of the worst. This one's gonna be bad too. I think the ones where the obsidian costs are low are pretty bad. Yeah, all the ones with the low obsidian costs are taking a while to execute. Not need you today, nor do we need you today. Well, actually, maybe we do, and I'm just doing this poorly. I mean, it's running. Do we get a reasonable number out of it? Get something that isn't 1366. I think if we get a 1366, I'm probably done for the night, and I'll try to figure it out tomorrow. No, we got 1366 again, and we know that's not the right answer. Even with the, I guess, most naive implementation of the logic here, like the slowest possible search, which is kind of weird. Oh, wait. Why do we think the answer is 8 now for geodes? I mean, we can... Oh, there we go. But no, we got the same answer for both of these. Anything I missed? This is incredibly slow without the safeguard against just doing nothing, basically. Like, are we just exploring infinite state here? Like, how? I guess we could just cap. Okay. Maybe an optimization is max. Oh god, what is it? It's gonna be ob clay. There's no way like, this is the most possible stuff we could ever use for ore, right? So let's just cap it at this. I have no idea if this is good or not. It looks like it's not good. Huh.
I don't understand. What do you want?
Oh no, I mean, I want min. I mean, it optimizes, but it's not that. It's just like we never possibly want to go over that amount of. Oh, wait, wow, we get a bigger number here. Oh, okay. How we can solve this tonight? You no longer have enough blueprints to worry about quality levels. Oh god, it's geo-op times 2. So it's going to be determine the largest number of materials, multiply the three values together. So try to see what state we're getting stuck on. I think we're being too generous, maybe. The state search. Let's see what happens. How did... I don't understand still how changing the way it was putting state got me the correct answer. Like, what did I even do? We were doing this. I didn't change any of this. This was all the core logic. If anything, limiting this here should have reduced the search space rather than increasing it. I guess we should prune states where we've seen that count of bots already. That's not gonna terminate anytime soon. I mean, the good thing about recording this is I can go back and look at what exactly I changed between two runs. Yeah, I'm too confused and too tired to try to understand what happened. Okay, so this makes me think it's a binary search question on reverse engineering what the most optimal thing to do is. The fact that one way to achieve this is what was the change? Did I just make it so that you always do something free? But I think we're not. What's the heuristic here, right? These numbers here don't feel like nearly enough geodes. So I doubt it's the answer. Geodes. We got some pretty big numbers here, right? Is there a way to take two Tmux windows that are already open and put them side by side? Actually don't know the answer to that. These numbers are too small. I feel like I never am seeing like 9 geode mining robots. It's problematic. If we need to see a 56 here, we should be seeing at least like numbers in the 40s. Yeah, we're not getting 56s often. Search space. Yeah, as soon as we get into geode tracking mode, you just keep on making those bots, I guess. Didn't do it in time. by like minute 20. We should be seeing a lot more geodes than this. No. We're doing pretty horrifically. We should have started making the first robot at around like minute 20, and it just should have accelerated from there on out. Oh yeah, it's kind of slow because... Okay. I guess here the blueprint, is there a heuristic we can use? It takes 7 obby. Maybe we never try making those if we have... like... it's a bit different. Silly heuristic. And let's clamp these values differently. These numbers feel more promising. If there's in their 20s already by minute... oh wait, by minute 30? It should be in the 30s really, but... this won't even return properly, I already know that. ...32 open geodes by... oh, wait, that is right. Alright, well... pray? All the printing is what's slowed it down? We could just pray? This is a good enough heuristic? I wonder if restricting not building obsidian robots on 7 is correct. Maybe it would have been more optimal to get one of these robots one sooner. I mean, this is going quickly enough that I think we can just bite the bullet. We can just fiddle with the heuristic some more. What was our multi? What was it? Day 16? What would happen if we just kind of yoinked this? Like, whoa. Just in case we need to change the heuristic. What? Why delete? CPUs go brr. If this isn't the right answer, I think we need to just fiddle with the heuristics a bit more, which is why I want what? So it takes one position arguments. Oh. Does this work? Can you do that on this sort of an object? That's serial. Thank you, Vim, for stopping me from wrecking myself. Let's oh, I don't want to do that in Vim. I mean, we're running the sample correctly, right? We're getting 56 and 62, which is quite promising. Let me just, let's see, not print all this stuff. Int object is not subscriptable. What is a suited return? Can't I just operate on this? the generator. Oh, so dumb. Okay, we'll see if we have to change around the heuristics. But hopefully not. Too high. That's interesting. I didn't think I'd be getting a too high answer. Especially because on the sample, we're... That's a 62 times 56. Should be around 3k something, yeah. Why would we be too high, is the question. Too high implies the simulation was wrong. You would have expected a too low, but not a too high. Oh wait, for each of the first 3 blueprints? Oh, am I just misreading things? Wow. I thought it was the first most of the blueprints that are the like highest. You do them. Why would they make it so that you don't have to simulate all of these? I wonder. Because the trick that the heuristics that I'm using actually do work for doing part 2 in a reasonable amount of time. Oh well. Anyways, I will probably jump to real time just so that this video is complete before I head to bed, and then explain the answer so that the VOD actually is somewhat meaningful. Okay, we should be back for part 2. I mean, the explanation. So let me just jump ahead over to here, and we'll bump up the font size everywhere a little bit. This code is still quite ugly. But I think I'll just try to go over the core interesting parts of the problem, or what allowed me to get an answer. Who knows if it's actually the intended solution or not. But today's problem is called Not Enough Minerals, and it involves basically simulating this game of a bunch of robots that are mining different materials. This is very reminiscent, I guess, of like a cookie clicker type game where every turn, each of your robots is like a clicker, and it'll mine one more of the type of robot it is. And once you have enough of a resource, you can spend a certain amount to build another robot to kind of make it more efficient to mine that type of resource going forward. Because here, every minute, we're only getting 1 ore. But if we spend 2 ore to make a clay collecting robot, now every minute we get 1 more clay. And so the question is, as you work up this chain, you can pay ore to make a clay robot, pay ore and clay to make an obsidian robot, and pay ore and obsidian to make a geode robot. So the geode robot is the important one because basically what part 1 asks is, at the end of 24 minutes, given a blueprint, so a blueprint is a set of constraints on the costs and the cost of different robots, what is the highest number of geodes that you could have mined by kind of allocating your robots in the optimal way. So in theory, this is just a simple graph search question, right? Where we have a notion of a state. So here I'm representing the state as how many minutes have passed, how many of each robot we have, and how many of each resource we have. And then for each stage in the search, we do the typical thing that we do in a BFS or any sort of graph search, right? We check if we've seen the state before. If we have, we prune it, we don't explore any further. If we're at the end, as in 24 minutes have passed, we can check if we have more geodes than we've seen in the past, otherwise continue. And then we have a series of possible state transitions. So what happens in the game is we can check if we can build any robots based on the resources that we currently have. So for example, if we have enough ore and we have enough obsidian to build a geode robot, we can do that. So here I'm representing the next state as adding an extra geode robot and subtracting the cost of ore and obsidian. And a similar thing for building all of these types of robots. There's also the case where we don't build any types of robots. In that case, we just tick forward in time. And then here is where we actually acquire resources. The reason I did it this way is just to match the simulation of the game more closely, because you can see at each tick we have to decide to spend the ore at the start of the minute to build the robot. Then we gain our resources, and then the robot is complete. So just to make sure there weren't any weird things about overspending resources because we incremented it at the same time as trying to build the robot, I did it this way. So here the addition of the resources is just done here. Our next state we put on the horizon is actually what we had in this current state plus the number of each bots we have producing the resource. So in theory, this should be all it takes to simulate it. But the problem is 24 steps is long enough that it's really, really slow, and the state grows to more than RAM is reasonable to hold, as you could tell from watching the VOD, I guess, and seeing that it was occupying like half my RAM or whatever. And so in order to make this more optimal, we have to come up with a series of heuristics to prune bad states that will never be fruitful. And I guess I'll just walk through some of the ones that I came up with. I have no idea whether these were intended, but this seems to be enough to get a reasonable runtime. Like if we go and run the code without doing any parallelism shenanigans, we can run part 1 in like a few seconds, and then we can run part 2 in a few seconds as well. So it's like 4 seconds each. There's probably a much better solution, but this was good enough to get the answers, right? So what are some of these optimizations? Well, first of all, you can see at the end of one of these simulations, we end up having a ton of clay this clay will never be able to be spent. No matter if we try to make one obsidian robot every single turn, we would never get through this clay. And likewise, we can run into a situation with ore too. And so we can compute a sort of cap on how much clay or ore we want to care about, and at any given state, we just basically constrain the levels of those resources that we have so that we're not just dirtying our search space with a bunch of new things. Like, who cares if I have two states that are exactly the same, but in one of them I have 1,000 ore, and in one of them I have 1,001 ore. Functionally to the search, or trying to find a result, these are exactly the same, and we would rather prune more paths earlier rather than later because they grow exponentially. So that's one optimization. Another optimization is to not use this entire state as the key for whether we've seen a state or not. Rather, all I care about for the key is how many minutes we're at and how many robots we have. Then if we've seen a state that looks similar to that, we can go through and check, well, how many of each resource do we have at that given point in time. And if all of our resources are less than or equal to that state, we don't have to explore it any further because we've already visited sort of this state in a more optimal situation. We've had the exact same number of robots at the exact same time, but we've been richer, for lack of a better term. So again, these two states are functionally identical, but if we're richer, we would rather just explore the richer state because it will always be more fruitful than the state in which we're poorer. I think the last optimization that made this actually possible is these things after the AND clauses in our building bots state transitions. If you analyze the inputs here, at a certain point, we want to stop building ore robots. That's kind of a waste of time. It's not going to help us get any further because the bottleneck is actually on the more valuable resources like clay or obsidian. And so we have some heuristics here where if we have any geode bots, we just stop trying to build ore bots or clay bots because there's no reason to. If we're rich enough to have gotten one geode bot, our bottleneck in trying to maximize the amount of geodes we make is how much obsidian we have. And usually, you know, by that point we have enough robots that we don't have to waste time building clay bots or ore bots to keep up with obsidian bot production. And for deciding if we want to build obsidian bots or not, it gets a little more complicated. I arbitrarily picked this number based on looking at the input and the sample input for part 2, which basically had us still making some obsidian robots every once in a while, but once we had enough geode robots, we don't go back. Like, we had enough obsidian robots to satisfy our rate of geode robot production. There's probably some mathematical way you can formulate some function for determining when that cutoff should be, but my plan for just solving the question would have been to mess around with the numbers and just fiddle around with it if we were too high or too low. So that's a restriction on whether we are trying to build an obsidian bot or not. And so that gives us the answer for part 1. This optimization here was the one more important for part 2, because in part 2, rather than simulating 24 steps, like we did in part 1, we're up to 32 steps, which doesn't seem like a lot more, but with how exponential this problem can grow, it actually is a lot more. Well, fortunately, we don't even have to simulate that for all 32 steps for every blueprint. We only have to do it on the first 3 blueprints here, which is I guess important to read. I literally saw this and my brain just glazed over what it actually meant, unfortunately. But yeah, with all of these heuristics, you know, we can run and get the answer in, you know, a few seconds. It'll be interesting to see if some sort of A star or better heuristic on which states to explore next gives an even better result. I'm sure it is, but I didn't come out with it over the course of solving this problem. But happy we did it in one sitting.